All right, let's dive into the world of aerodynamics engineer interviews. You're aiming for this awesome career, and we're here to help you nail that interview.
Exactly, using RoleCatcher's insights, like sample questions, to go beyond just basic answers.
It's like your personal flight simulator for the interview. We'll analyze questions, decode what interviewers are really after, and give you strategies to impress.
And don't forget RoleCatcher's AI. It tailors your CV and even scores it against job requirements. It also provides feedback on your video practice responses.
It's like a secret weapon. So, ready to tackle some interview questions?
Let's do it.
All right, first up, can you explain the Bernoulli principle? Seems basic, but I bet interviewers are looking for more than just a definition.
You're right. They want to see your understanding of the fundamentals. It's not just reciting the definition, it's showing how it applies in the real world, like how it explains lift on an airfoil.
So how should someone approach this? What makes an answer stand out?
Go beyond faster air, lower pressure. Connect it to the bigger picture.
Yeah.
Talk about pressure differences above and below the wing and how that generates lift. Even mention how engineers use this principle to optimize airfoil shapes for lift.
That's a great point. And RoleCatcher can personalize your answer based on your experience and the job. What kind of follow-up questions might come up?
They could dig deeper, like the relationship between lift and angle of attack, or how Bernoulli's principle relates to drag or stall. Be ready to think on your feet.
Great advice.
Yeah.
Okay, next, can you describe the different types of drag? Drag's the enemy of efficiency, right? I'm sure they want to see if you know the different types.
Exactly. They're checking your grasp of this key concept. Be ready to discuss parasite drag, induced drag, wave drag. Explain how each is generated and how it affects aircraft performance.
But it's not just about listing them, right? How can you make your answer memorable?
Real-world examples. Mention how streamlining reduces parasite drag, or how wingtip vortices contribute to induced drag. Maybe touch on how supersonic flight creates wave drag. The more relatable examples, the better.
That makes sense. RoleCatcher's tailored sample answer can help connect theory and practice. Any potential follow-up questions here?
They might ask about methods for minimizing each type of drag, or how drag changes at different speeds. They might even ask you to calculate drag for a given scenario, so be ready to apply your knowledge.
Got it. Next question. How do you calculate the lift coefficient of an airfoil? Oh, sounds like it's getting technical.
Absolutely. This tests your knowledge of lift generation. You need to confidently define lift coefficient and explain the formula.
So more than just memorizing a formula, what makes a response really good?
Show deeper understanding. Explain the variables. Air density, velocity, wing area. Don't just plug in numbers. Show you understand why those variables matter.
Great advice. RoleCatcher can personalize this, considering the job requirements. Any follow-up questions for this one?
They might ask how factors like angle of attack or airfoil shape affect the lift coefficient, or get into complex scenarios, like calculating lift in different flight regimes. So be prepared to go beyond the basics.
All right, next one. How do you optimize the design of an airfoil for maximum lift? Now, this sounds like a chance to show off some creativity.
Exactly. This assesses your ability to apply aerodynamic principles to design challenges. Be ready to discuss factors like angle of attack, camber, and thickness. Explain how changing those impacts performance.
But it's not just about maximizing lift, right? There must be trade-offs.
Exactly.
Yeah.
So you understand those. Like, increasing camber can boost lift, but also increase drag. It's finding the sweet spot between lift and other factors, like
Yeah.
drag and structural integrity.
It's a balancing act. RoleCatcher's personalized answer can help find that balance. Potential follow-up questions.
They might ask about specific design considerations for different aircraft types, or how maximizing lift changes in different flight conditions. So be ready to tailor your knowledge.
Okay, moving on to a powerful tool. How do you simulate airflow over an aircraft using computational fluid dynamics? CFD is a game changer, right?
Absolutely. They want to know if you're comfortable with this essential tool. Explain the core principles of CFD, including numerical methods and meshing techniques.
So more than just saying, we create a computer model, what details impress?
Take them behind the scenes. Talk about creating a virtual model and using software to simulate airflow. Explain how the results are used for things like optimizing shape for reduced drag or improved lift. You can even mention specific CFD software packages.
Great advice. RoleCatcher's personalized answer can incorporate your experience with CFD software. What about potential follow-up questions?
They might ask about the limitations of CFD, or how you validate results against real-world data from wind tunnel testing. They could also dig into specific CFD techniques or challenges.
Great insights. Next question. How do you design an aircraft wing to minimize drag? Back to design, but this time focused on drag reduction.
Exactly. This requires deep understanding of how design choices impact drag. Discuss things like aspect ratio, wing sweep, and airfoil shape, and how each contributes to minimizing drag.
So it's more than just making the wing smooth.
Exactly. You need to explain how each design choice impacts drag, and how to balance those for optimal performance. For example, increasing aspect ratio reduces induced drag but might add weight. It's all about understanding the trade-offs.
Sounds like a lot to consider. RoleCatcher's tailored answer can guide you. Follow-up questions.
They might ask about specific techniques for minimizing different types of drag, or get you to compare the drag characteristics of various wing designs. So be ready to showcase your knowledge.
Okay, let's step away from the digital world. How do you analyze and interpret wind tunnel test data? Wind tunnel testing is classic aerodynamics, right?
Absolutely. They want to see if you can bridge theory and real-world testing. Explain the different types of wind tunnel tests and the data they generate.
It's not just observing airflow, right? What kind of data are we talking about?
Things like pressure measurements, force and moment data, and flow visualization techniques. Explain how this data helps understand how a design performs, and how it refines the design. You could even mention visualization techniques like smoke trails or pressure-sensitive paint.
RoleCatcher's personalized answer will include examples from your experience. Potential follow-up questions?
They might ask about challenges in wind tunnel testing, or how you correlate wind tunnel data with CFD results. They could even ask you to interpret a sample data set, or explain how you'd address unexpected results.
All right, into high-speed flight. How do you account for compressibility effects in aircraft design? Sounds supersonic.
You got it. They're evaluating your understanding of compressible flow and its impact. Explain the basics like the Mach number, and how pressure, temperature, and density change at high speeds.
So it's more than just going faster. What are some key concepts to highlight?
Definitely discuss shock waves, explain how they form, how they create drag, and how they affect lift. Also, talk about how engineers mitigate those effects through design, like swept wings or area ruling.
Designing for supersonic flight brings new challenges. RoleCatcher's personalized answer can help hit the key points. Follow-up questions.
They might ask about specific challenges in designing for supersonic flight, or how you use CFD to model compressible flow. They could even ask you to compare design approaches for mitigating compressibility.
All right, last question for now. How do you assess the stability and control of an aircraft? Sounds fundamental to safe flight.
It is. This goes into aircraft dynamics and how to analyze and optimize them. Explain the different types of stability: longitudinal, lateral, and directional.
So more than just staying level, there are different dimensions of stability.
Exactly. You need to explain how each type contributes to controlled flight. Discuss how factors like weight and balance, control surfaces, and aerodynamic design affect stability. You can mention techniques like flight testing and simulations.
It's a complex interplay of factors. RoleCatcher's answer can help structure your response. What follow-up questions should someone be prepared for?
They might ask you to explain specific stability criteria, or how to address stability issues during testing. They could even delve into advanced concepts, like control augmentation systems or fly-by-wire technology.
That's a lot to cover. But with preparation in RoleCatcher, anyone can tackle these questions. We've covered a lot, but we'll be back to dive into more insights about aerodynamics engineering.
You've really gotten a grasp of those technical questions. Now let's step back and look at the bigger picture of this career.
Sounds good. So, beyond nailing those technical questions, what else should I consider as I prep for this interview and this career?
Well, you're entering a field that's in high demand. The need for efficient and green transportation is constantly growing, meaning more opportunities for skilled aerodynamics engineers.
That's great to hear. But it's also a very competitive field, right?
It is. A solid education is key. Think aerospace engineering, mechanical engineering, or aeronautical engineering. And continuous learning is crucial. You need to stay updated on the latest technologies and trends.
Speaking of staying updated, RoleCatcher outlines typical career paths, right?
Yeah.
From entry level to senior roles.
It does, breaking down the typical tasks and responsibilities at each stage. Like an entry-level engineer might assist with analysis and design under senior engineer's guidance. As you gain experience, you take on more, eventually leading projects and teams.
So there's a clear path for growth. What about the day-to-day? What are the pros and cons of being an aerodynamics engineer?
Well, as we said, the high demand is a big plus. It's a field with real impact. You're designing things that move people and goods around the world. The potential for innovation is huge.
Sounds amazing. What about the downsides?
It's demanding, long hours and pressure. You need to be a strong problem solver, detail-oriented, and be prepared for potential location limitations. Jobs might be concentrated in certain areas like aerospace or automotive hubs.
Not always smooth sailing, but the rewards seem worth it. Before we go on, let's touch on RoleCatcher's AI and how it analyzes CVs.
Right, it's an incredibly useful tool. It scores your CV against job descriptions, so you see where you stand in terms of the skills employers want.
Like seeing into the recruiter's mind.
Exactly. And it goes beyond just identifying gaps. It suggests how to tailor your CV, like highlighting projects, skills, or matching the job description's language.
That's incredible, like having a career strategist. Okay, back to the interview questions. What else might they ask?
Here's a more involved one. Can you walk me through designing a wind tunnel experiment to test a new aircraft design's aerodynamic performance?
Wow, that's comprehensive. Not just knowing what a wind tunnel is, but understanding the whole process.
Exactly. They want a structured approach. Start by defining your objectives. What aerodynamic characteristics are you measuring? Lift, drag, stability.
So first, clarity on what you're trying to achieve.
Right. Then consider the right type of wind tunnel. Different types have different advantages and limitations.
So know your wind tunnels. What influences the choice?
Things like model size and speed, required Reynolds number, and the data you need. Like, a low-speed tunnel might be okay for lift and drag on a small model, but a supersonic tunnel's needed for high-speed conditions.
Each type has a purpose. So objective set, wind tunnel chosen, what's next?
Design the model itself, a scaled-down replica, paying attention to details affecting airflow.
Even tiny imperfections could matter.
Absolutely. Accuracy is key. You also decide how to mount the model. Wires, sting, platform.
Lots of planning before even turning it on.
There is, and instrumentation is important. Sensors for pressure, force, velocity.
So more than just looking, you're collecting data.
Right. Then analyze and interpret that data. Compare to predictions, find discrepancies or unexpected results.
Piecing together a performance puzzle.
Exactly. That's what they're looking for. Someone understanding the whole process.
Not just theory, but application.
Precisely. A great chance to showcase that.
I imagine they'll have follow-up questions.
For sure. Maybe about specific challenges you faced, or troubleshooting unexpected results. They could go deeper into data analysis techniques.
It's about showing critical thinking and problem solving.
Right. And RoleCatcher can help you prepare, providing personalized answers based on your experience and the job.
Like a secret weapon for the interview. Okay, let's move on.
All right, here's one that gets to aircraft design's core. What are key considerations when designing for stability and control?
Stability and control are essential, right? It's about safety and predictability, not just speed and aerodynamics.
Absolutely. They're fundamental. This question assesses your understanding of the contributing factors.
Where would you start with this one?
Explaining the different types of stability. Longitudinal for pitch, lateral for roll, and directional for yaw.
Setting the foundation with the different dimensions.
Exactly. Then, the specific design considerations for each type. For longitudinal stability, the center of gravity's location relative to the aerodynamic center is crucial. Too far forward, too stable and sluggish. Too far aft, unstable and prone to pitching.
Finding the balanced sweet spot.
Precisely. Illustrate this with the horizontal stabilizer. It creates a downward force, counteracting the wing's pitching moments.
So it keeps the aircraft from pitching too much.
Exactly. For lateral stability, the wing's dihedral angle is key.
The upward slant.
Right. When the aircraft rolls, it creates a lift difference between wings,
Yeah,
helping return to level flight.
like a self-correction mechanism.
Exactly. And the vertical stabilizer is crucial for directional stability. Keeps the aircraft pointed right, preventing yawing.
Like a boat's rudder.
Exactly. Now, there's more than those basic features to consider. Weight and balance are crucial. Uneven distribution affects stability. Control surfaces matter too. Ailerons, rudder, elevator, all control the motion.
It's a complex interplay of design and systems.
It is, and they want to see you understand that.
Not just definitions, but the bigger picture.
Exactly. Remember, RoleCatcher's personalized answers can help here, highlighting key considerations.
It's a cheat sheet, almost.
Well, not really, but a valuable resource for structuring your thoughts.
And hitting the key points. They probably have follow-up questions on this too.
Absolutely. Maybe elaborating on design features or systems, or a hypothetical problem and asking for a solution.
Showing problem solving.
Right, and critical and creative thinking.
Okay, let's tackle another tough one.
Here's one testing your understanding of aerodynamics and context. How would you design an aircraft for high-altitude flight?
High-altitude flight has unique challenges, right? Thinner air, affecting lift and drag, and temperature and pressure, too.
You're right. It requires a deep understanding of how those factors impact performance.
Where do you even start?
With the fundamentals of aerodynamics, how does lift change at higher altitudes? How does drag change?
Laying the groundwork with the basics.
Exactly. Then think about specific solutions.
For example,
Well, maintaining lift in thin air is a big challenge. You might increase wing area or use a different airfoil, more efficient at high altitudes.
compensating for the reduced air density.
Right. Engine performance at high altitudes matters too. Jets, for example, operate differently in thin air. You might need a different engine or modify it for enough thrust.
Balancing aerodynamics and engine performance.
It is. And consider structural integrity, too. Fuselage and wings need to withstand the stresses, where temperature and pressure differences are more extreme.
Not just aerodynamic design, but durability and safety, too.
Absolutely. And don't forget the human factor. Passengers and crew need to breathe. Pressurized cabins, supplemental oxygen.
You're thinking about the entire system.
Exactly. High-altitude design needs a holistic approach.
Not just one aspect, but the interconnected factors.
Precisely. They want someone who can demonstrate that systems-level thinking.
Seeing beyond your area and considering the big picture.
Exactly. RoleCatcher's personalized answers can help here too, highlighting key considerations for high-altitude flight.
A valuable resource for standing out.
Absolutely.
Okay, let's move on.
All right, here's one, testing your knowledge of a specific phenomenon. Can you explain boundary layer separation and its implications for performance?
Boundary layer separation. That's technical. What is a boundary layer and why does it matter?
The boundary layer is a thin layer of air forming on a surface as it moves through fluid, like air. It's caused by friction between the object and the fluid.
So, air clinging to the aircraft.
Exactly. And its behavior impacts performance significantly.
How so?
Under certain conditions, it can separate from the surface, usually when airflow meets a sharp curve or a sudden pressure change.
Instead of smooth flow, it detaches and becomes turbulent.
Precisely. This separation has two main implications. First, increased drag. When it separates, it creates a low-pressure region behind it, like a suction cup, pulling back and increasing drag.
So making the aircraft less aerodynamic.
Exactly. Second, reduce lift. Separation disrupts smooth airflow over the wing, reducing the pressure difference. Reducing lift?
A double whammy.
Exactly. These effects are more pronounced at high angles of attack, where separation is more likely.
Critical for designers, especially for maneuvers with high angles of attack.
Absolutely. The interviewer wants to see you understand this and its implications.
Not just the definition, but how it affects real-world performance.
Exactly. Remember, RoleCatcher's personalized answers can help here, highlighting the key points.
A great resource to demonstrate your understanding.
Absolutely.
Okay, let's continue.
All right, this one tests your knowledge of different design approaches. Can you compare and contrast swept wings and delta wings?
Swept wings and delta wings, classic designs, right? From fighter jets to passenger planes.
Right. Both have unique advantages and disadvantages. The choice depends on the aircraft's requirements.
So swept wings first. What are their advantages?
They delay wave drag, a major problem at transonic and supersonic speeds.
The drag from shock waves.
Exactly. Approaching the speed of sound, shock waves form on wings, creating drag and potentially causing instability.
So swept wings are designed to mitigate that.
Right. Sweeping them back reduces the effective chord length, reducing shock wave strength and delaying formation.
Like making the airflow think the wing is shorter.
Exactly. Allowing flight at higher speeds with less wave drag.
Ingenious. But what are the disadvantages?
They tend to have lower lift coefficients at low speeds.
Not as efficient at generating lift when flying slowly.
Right. The sweep angle reduces effective wing area, reducing lift.
A trade-off between high-speed and low-speed performance.
Exactly. That's why they're typically on aircraft designed for high speeds, like fighters and airliners.
Okay, now delta wings, their advantages.
They have a high lift-to-drag ratio, especially at high angles of attack.
So efficient at generating lift even when pitched up sharply.
Exactly. The large surface area creates a lot of vortex lift.
The lift from swirling air along the leading edge.
Right. Delta wings are good at generating vortex lift, maintaining lift at high angles of attack.
So good for maneuvering quickly, like fighter jets.
Exactly. They're also structurally efficient, lighter and stronger than other designs.
High lift, low drag, strong structure.
Pretty much, but they have disadvantages too.
I imagine they might not be as efficient at high speeds as swept wings.
You're right. They can create a lot of wave drag at transonic and supersonic speeds, because of the large surface area and sharp leading edge.
So not ideal for very high speed.
Exactly. Another disadvantage is control at low speeds. The vortex lift can make them unstable.
A trade-off between maneuverability and stability.
Precisely. That's why they're usually on aircraft prioritizing maneuverability, like fighter jets.
So the choice depends on the specific needs.
Exactly. The interviewer wants to see you understand these trade-offs and can make design decisions.
Not just definitions, but applying knowledge.
Right. RoleCatcher can help you prepare for this too, highlighting the advantages and disadvantages.
It's a great resource for showing your understanding of design principles.
Absolutely.
Okay, what's next?
This one tests your knowledge of a safety feature. Can you explain how flaps work and their role in flight?
Flaps. The movable panels on the trailing edge, right. I know they're for takeoff and landing, but how do they work?
Right, they're essential for safe takeoff and landing, increasing lift and drag, allowing slower speeds and steeper angles of attack.
So they make the wing more efficient at low speeds.
Exactly. By changing the wing's shape and camber.
The wing's curvature.
Right. Extending flaps increases camber, increasing the pressure difference and thus lift.
Adding curve for more lift.
Exactly. They also increase drag, disrupting the airflow, helping slow down during landing.
Like air brakes for the wings.
In a way, yes, but also essential for generating lift at low speeds.
So how do they actually work?
Different types, but all change the wing shape. Some, like plain or split flaps, simply extend down.
Increasing the surface area.
Right. Others, like slotted or Fowler flaps, are more complex, extending down and sliding back, further increasing camber and area.
Like an extension to the wing.
Exactly. The choice depends on the aircraft's needs. For example, large airliners typically use slotted or Fowler flaps for a big lift increase.
So much engineering in a simple flap.
It is. They want to see you understand the different types, how they work, and their role.
Not just a basic explanation, but a deep understanding.
Exactly. RoleCatcher can help you prepare for this too.
Yeah.
Highlighting the key points.
Great for showcasing your knowledge.
Absolutely.
What else might they ask?
This one tests your understanding of how aerodynamics and structure relate. How do you consider their interaction when designing an aircraft?
Interesting. It's not just aerodynamics, but also making sure it withstands flight forces.
Exactly. They're two sides of the same coin, considered together during design.
How do you do that?
Start by understanding the aerodynamic loads during flight.
What kind of loads?
Lift, drag, maneuvering loads, creating stresses on the structure. It needs to be strong enough.
Balancing aerodynamic efficiency and structural integrity.
Precisely. This is where structural analysis comes in. Software simulates the loads and analyzes the stresses.
Running virtual tests.
Right. Then adjustments are made based on those results. Strengthening areas, changing the shape to reduce loads.
A constant refinement process.
It is crucial for safety and reliability.
So they're looking for someone understanding this and explaining how it's considered.
Exactly. Not just designing aerodynamically, but safely and reliably.
And RoleCatcher can help here too.
Providing personalized answers, highlighting the key considerations.
A great resource for showcasing your understanding.
Absolutely.
Okay, on to the next question.
This one tests your knowledge about a specific type of aircraft. What are some unique aerodynamic challenges of designing a supersonic aircraft?
Supersonic aircraft, the ones breaking the sound barrier. What makes them so challenging aerodynamically?
Supersonic flight has unique challenges.
Like what?
One of the biggest is wave drag. Approaching the speed of sound, shock waves form on the wings and fuselage, creating a lot of drag and potential instability.
Like hitting a wall of air?
In a way, yes. And this drag increases a lot once you go supersonic.
A major obstacle then.
Exactly. That's why they have specific features to minimize wave drag.
For example?
Swept wings. They delay the onset of wave drag by reducing the effective chord length.
Like making the airflow think the wing is shorter.
Exactly. Allowing supersonic speeds with less wave drag.
Clever. Any other features?
Area ruling. Shaping the fuselage to minimize the area where shock waves form.
Streamlining to reduce their impact.
Exactly. Significantly reducing drag and improving supersonic performance.
So much thought goes into the details.
It does, highlighting the importance of understanding the physics of supersonic flow.
So they want someone understanding the challenges.
Yeah.
And knowing how to address them through design.
Exactly. Someone who can think critically and solve complex problems.
RoleCatcher can help here too.
With personalized answers highlighting key considerations for supersonic design.
A great resource to show your knowledge.
Absolutely.
I think we've covered the technical questions well. Let's talk about some of the softer skills that are important.
Okay, like what?
Things like communication, teamwork, problem solving. Essential for any engineer, but especially in a field as complex and collaborative as aerodynamics.
You're absolutely right. Aerodynamics engineers work in large teams. Other engineers, technicians, managers.
So good communication is essential for effective collaboration.
Exactly. You need to communicate clearly and concisely, both verbally and in writing.
And be a good listener to
Yes.
understand and incorporate feedback.
Absolutely. Teamwork is also crucial. Aerodynamics projects are large and complex, needing many contributions.
So you need to work well in a team, contributing your expertise while respecting others.
Right. And problem solving is always essential for engineers, especially in aerodynamics. You constantly face new challenges and need to find solutions.
So they'll be looking for critical thinking, data analysis, and creative solutions.
Exactly. And the ability to learn from mistakes and adapt.
Being a flexible and resourceful engineer.
Precisely.
Okay, we've covered a lot. Technical skills, soft skills, and using resources like RoleCatcher.
Right. Giving a good overview of what to expect.
I agree. But before we finish this part, let's circle back to showcasing your passion.
Excellent point. Skills and experience are important, but passion sets you apart.
How can you convey that passion during the interview?
Be genuine, don't force it or pretend.
Authenticity is key.
Absolutely. Be ready to talk about what sparked your interest, what fascinates you about this field, your goals.
Maybe you were inspired by a particular aircraft.
Right, or maybe by the environmental challenges.
Whatever it is, let it show.
Exactly. And ask questions. Show curiosity.
Engage. Show you're not just there for a job.
Right. Passion is contagious. It impacts how they see you.
Be yourself, be passionate, showcase your knowledge and enthusiasm. Great advice for anyone preparing.
I agree.
We've covered a lot in this episode. Technical questions, soft skills, career insights, and using RoleCatcher. But there's more to come. In part 3, we'll dive into some final tips and strategies.
Sounds good. I'm looking forward to it.
All right, back for the final part of our Aerodynamics Engineer Interview Deep Dive. We've covered a ton, from technical questions to soft skills and career insights.
We've prepped you on everything from the Bernoulli principle to designing for supersonic speeds.
And remember, RoleCatcher. It's your secret weapon for tailoring your CV, practicing answers, and getting AI feedback.
Now, let's focus on those final tips and strategies that can really make you shine.
Because even with all the knowledge, those little things make you stand out. What comes to mind first?
First impressions are key. Professional dress, be on time, whether in person or virtual.
Seems obvious, but important. Even virtually, background clutter or noise matters.
Absolutely. Beyond appearances, be confident but not arrogant. Show your hard work, but be respectful and open to learning.
That's a tough balance to strike. They want someone eager to learn, not a know-it-all.
Exactly. Speaking of growth, talk about your career goals and how this role fits in. Show you're invested in a career, not just looking for a job.
Makes sense, showing you're thinking long-term. We talked about practicing answers. Any specific approach that works?
Don't just memorize. Understand the concepts and articulate them clearly. Tell a story. Connect technical details to real-world examples.
Show how you think, not just what you know.
Right. And be enthusiastic. Let your passion show. Interviewers love that.
Enthusiasm is contagious. Okay, prep work, first impressions, answering questions. What about when it gets tough? What if they ask something you don't know?
It happens, and it's okay to admit it, but don't just say, I don't know. Show your problem-solving skills. Say something like, I haven't seen that, but based on my understanding, I'd approach it by. Then outline your thought process.
Turning a weakness into a strength. Showing you can think on your feet and find solutions.
Right. And remember, it's a two-way street. Ask thoughtful questions about the company and the role. Show you've done your homework and are engaged.
It's about you evaluating them too.
Exactly. And follow up afterward. A thank you email reiterating your interest and mentioning something specific you discuss.
A simple gesture that goes a long way. Okay, we've covered do's and don'ts, technical stuff, the little things. Any final advice?
You've got this. You've worked hard, you're passionate, and you have the tools and knowledge.
And RoleCatcher is there every step of the way.
So go out there, be confident, be yourself, and let your passion for aerodynamics take off.
That's a wrap on our deep dive into Aerodynamics Engineer Interviews. We hope you found it informative and inspiring.
And we're confident that with the right preparation and confidence, you'll soar in your career.
Thanks for joining us.